So yes, I'm Lizzie. I work at the Lapworth Museum of Geology, and we're also joined by my colleague Arona, who'll be manning the chat for us. And we are here today to explore everything to do with volcanoes inside and out. So we're going to be thinking about why volcanoes exist, and the insides of the volcanoes, and what they produce during their eruptions as well. As I said, as we go along, any questions or any answers, pop them into our chat box for us. Okay, so you might have been to the Lapworth before, you might not have been. I know some of you are joining from Birmingham. We are a Birmingham-based museum. We're actually at the University of Birmingham. So if we go onto this slide here, we can see here, this is where our museum is. We're in the middle of England in Birmingham, and we are part of the University of Birmingham. So here's one of the larger buildings from the University of Birmingham. And we're on the end of one of those buildings here. This is us. And when you walk into our museum, you will be greeted by everything to do with geology. So rocks, minerals, fossils, all about earthquakes, volcanoes, glaciers, anything to do with how our Earth works, anything to do with the history of our Earth. Now, if you've been before, fantastic. We're open every day and we're always free to visit. And if you haven't been before, then we'd love to see you there. And when you walk in, the first thing you will see in our museum is Rory the dinosaur. So some of you might have met Rory the dinosaur before, some of you might not. Does anybody know what kind of dinosaur Rory is? Lots of people are guessing that Rory is a T-Rex or a Tyrannosaurus Rex. Now, Rory is a bit smaller than a T-Rex. I can see where you've got that idea. We've got that same big head, same small arms, and we are on two legs here. But Rory's almost half the size of a T-Rex. I can see some of you guessing that Rory is an Allosaurus, and that's absolutely right. So Rory was an Allosaurus dinosaur. It was a hunter, it was a carnivore or a meat eater. Does anybody know what time period Rory was alive in? Any guesses at all? There are some films named after this time. Okay, so lots of you are guessing the Jurassic. That's absolutely right. Rory is from the Jurassic time period. Now, the Jurassic time period was a long, long time ago. In fact, if we have a little look here, the Jurassic time period was between 201 and 145 million years ago. So it was a very, very long time ago. And actually, our Earth looked very different when Rory was alive. So this is the world that Rory lived in. And this is the world that we live in today. And we can see that in our world, we've got North America here, South America here. We've got Africa here, Europe, Asia, Australasia, and Antarctica. But when Rory was alive, the countries are in different places. The continents and the land was in different positions. So we can see that, you can see where South America will end up being. But at the moment, we've got land attached to it here and land attached here. We're also missing land from up here because it's in a different position. So actually, our Earth has changed over time. The position of our land has moved. And that's something that helps us to explain why things like volcanoes and earthquakes happen. So as we go along, you might have an activity sheet with you. So if we just look here, this is the activity sheet that you could have. Arona will share the link to the activity sheet if you haven't been able to access it, and you can just follow along on your screen. And as you can see here, this is all about volcanoes and earthquakes. And our first box on the left is the Earth has layers question. And on this question, we are going to try and work out what the layers are. The box is red, and on my slide, I now have a red star. So this tells us that answers to the red box are going to be coming up, and we can work together to try and get those answers out. So first of all, what does the inside of our Earth look like? If we were to cut our Earth in half and then pull out the different layers, we would have 1, 2, 3, 4 different parts to it. Does anybody know what the outside layer of our Earth is called? Oh, amazing. You're all amazing. So this layer here is called the crust. Just like a piece of bread, we've got that crust around the outside. This is our crust. And the crust is a thin layer. It's quite cool. And it's where we find our land and we find our oceans as well. So we live on the crust. Okay, it's an important layer. But next, underneath our crust, we have an even thicker layer, a much thicker layer. This one here. Does anyone know what this layer is called underneath the crust? Oh, fantastic. If you're not sure, I'll give you a clue. It begins with an M. Oh, lots and lots of great answers. Yes, this is our mantle. So the mantle is directly underneath the crust that we are living on. Okay, so we've got crust, mantle. What happens next? What's this next layer? You all know very well, you know your structure of the Earth. Yeah, so after our mantle, we get our outer core. And our outer core is actually a liquid. It's very hot. It can be between 4,000 and 6,000 degrees C, and it flows very easily. And in the center here, this solid mass, what would we call this? Brill. So we've got our outer core here, the next in the middle, that is our inner core. So they are the 4 layers of our Earth, and they're very important because they're all very slightly different in temperature or whether they're a solid or a liquid. And these layers are one of the reasons why we're able to live on Earth. But today, when we're thinking about volcanoes and we're thinking about earthquakes, we need to think about these 2 layers here, the crust and the mantle. And first of all, I want you to imagine our Earth as a ball, and around the outside of it, we've got our crust. So we're imagining a globe. And then what I want you to do is imagine that you've rolled out the globe, you've flattened it down. And when we flatten it down, we end up with something that looks like this. And this looks just like our map of the world. But the difference is our map of the world has got these strange lines on. And that's because our crust is made up of lots and lots of pieces. It's not just one gigantic piece that wraps around the Earth. We've actually got some very large pieces, like this one here, the North American plate. And we've got some much smaller pieces, such as this Caribbean plate. Now we can imagine them like jigsaw pieces. They're all connected together. But if we were to be scientific, if we were using our science words for this, instead of jigsaw pieces, we would call them tectonic plates. So tectonic plates are pieces of our crust that are all connected together. And our tectonic plates are always moving. And some of them are moving in some directions, others are moving in the opposite direction. So we can start to work out how them moving can create volcanoes and earthquakes. So what I want everyone to do now is, I want you to take your hands and put them fingertip to fingertip. And we're going to imagine that our left hand is our North American plate, and our right hand is our Eurasian plate. I'm going to put them together. And what I want you to do now is I want you to move them apart very, very slowly. Because our North American plate is moving in one direction and our Eurasian plate is moving in the other direction. And we're forming this gap in the middle. And what do you think is going to fill that gap? Got some brilliant guesses. Let's have a little look at our pictures, see if that can help us. So when our plates are moving in opposite directions, hot magma from beneath the crust comes up and fills our gap. So we're not left with gigantic holes in our crust anymore. This hot magma comes up to the surface, and when it comes to the surface, eventually it will cool down. And if magma is coming up to the surface, what are we going to get forming along this edge or along this ridge here? Something that erupts. Fantastic. Yeah, so when our plates move away from each other, we get our volcanoes, because all of that magma has to come up somehow and it comes out as volcanoes. So, or volcanoes form. Okay, now we call these plates, when they move away from each other, we call them constructive. And that's because they're creating new land, they're creating new crust. All that magma comes up as lava and then it becomes solid rock. It forms new crust. So that's constructive when they're moving apart. Okay, next one. I'd like you to put your fingers together. So the next one that we're going to look at is our plates moving together. So this time we're going to say that our plate from our left hand is going to get pushed underneath the plate on our right hand. So this one's slowly being squashed deep into the earth. And when it gets squashed into the earth, it starts to melt. It's being pushed into this very, very hot area and it all starts to melt. And when it starts to melt, some of it might come up to the surface. So again, when we have our two plates coming together, one of them gets destroyed, destructive. And when it's destroyed, it helps to push magma up to the surface where we might find volcanoes as well. So two different ways that we can form volcanoes. The last way that our plates could move past each other, we're going to take our hands and this time we're going to put them on top of each other like this. And then we're going to move them so that we can see them. And this time our plates are going to move next to each other. So they're not moving away from each other. They're not moving towards each other. They're just rubbing past each other. And we don't get volcanoes when they rub past each other. What do you think we get instead? Brilliant. Yeah. Anytime that our plates rub past one another, we tend to get earthquakes. So first of all, we're just going to spend a quick 5 or 10 minutes thinking about earthquakes before we move to thinking about volcanoes that can form as well. So here we've got some pictures of different earthquakes or what's happened after an earthquake has happened. So we can see that sometimes earthquakes can be very, very big and cause damage to buildings. Sometimes they can cause big cracks in the roads. Sometimes they can just cause buildings to move a little bit. Sometimes they can cause a little bit of damage to some of the brickwork. Sometimes we don't even notice earthquakes happening. So earthquakes can come in lots of different sizes. Now, a couple of you are saying about an earthquake that happened the other night. Yes, that we had an earthquake in the UK. Yes, it was about 24 hours ago, 36 hours ago. And it was a fairly big earthquake for the UK, but quite a small earthquake compared to others that we can have across the globe. But we'll have a little look at some of the UK earthquakes in a moment. So earthquakes can happen wherever our plates rub past each other. So when one's being pushed under the other, they rub past each other here. And when they go past each other like this, they rub past each other completely. So we can get earthquakes in these two different ways. And that means that we tend to get earthquakes along the edges of our tectonic plates. We tend to get our earthquakes where they meet one another, where there's a chance for them to rub past each other. So if I click on this map now, we're going to go and have a look at some of the earthquakes that have hit in the last day. So in the last day, we can see that there have been earthquakes. We zoom in a bit. We can see that there have been earthquakes in all of the places that you can see little red or orange dots. Now, if we look at the pattern, almost all of these orange dots and red dots are near our plate boundaries, or near the edges of our tectonic plates. And that's because this is where they rub past. This is where the energy from them being moving together is released. And we can measure our earthquakes, giving them a number based on their size. So you can see lots of numbers along the side here. We've got some 5.4s, 2.6, 3.3. Does anybody know the machine we use, what the name is for the machine that we use to measure earthquakes? This is the machine. Do you know what it is called? Okay, brilliant. Got a couple of different guesses. Some of you have said it's called a seismograph or a seismometer. That's a name for the machine. Perfect. Seismometer pretty much just means amount of movement, size of the movement. And it measures how much the Earth has actually quaked or moved. So we can see here that big lines mean big movement. Little lines mean little movement. Some of you have said about the Richter scale. Again, the Richter scale is a way to give the size of an earthquake a number. So we use a seismometer to work out how big the movement is, and then we assign a number. We give the earthquake a number based on that amount of movement. Now, if it's a number 1, 2, 3 earthquake, you probably wouldn't even feel it. In fact, if you were walking along a path by a road and a big lorry went past, that would feel more of a quake than a number 1, 2, or 3 earthquake. If we start to get numbers 6, 7, 8, and 9, those are the earthquakes that start to cause the damage like we saw on our pictures. Much bigger earthquakes, more of the sort that you might hear about in the news. So if we go to our activity sheet, we can see that there's a blue star on my slide. So let's go to the activity sheet. And in the blue box down here, it says, what is the machine called that measures earthquakes? And the machine is a seismometer. And this is actually a seismometer that we have at the museum as well. So you can have a look at one too if you're ever able to come and visit us. Now, as I said before, earthquakes tend to happen along the edges of our plates where they meet each other. So in the UK, we're not likely to get that many earthquakes because we're not very close to where these plate boundaries are. So we don't tend to get very big earthquakes. But as somebody's already said, that doesn't mean we never get earthquakes, it's just that we tend to get little ones. And actually, in the UK, we tend to get between 200 and 300 earthquakes a year. So that works out at about 4 earthquakes a week, roughly. But most of us have never felt an earthquake happen. I never felt the earthquake that happened the other day in the Midlands, and I'm living in the Midlands. The earthquakes that we get are very, very small. In fact, one of the only large earthquakes that ever happened in the UK measured 6.1 on our Richter scale, but it happened in 1930. And sometimes that movement can be because of our plate tectonics. Sometimes there can be other causes of movement in certain locations as well, such as if a building was demolished, that can cause movement. So sometimes it's hard to work out exactly what caused the measurements that can be found on seismographs. So in the UK, between 200 and 300 earthquakes a year, we can see that a lot of those earthquakes happen in the mountainous regions of Scotland up here. But in some places in the world, they have to be a little bit more aware of when earthquakes might happen. So you can have a little look down here at this country. You can see that the country's actually got a boundary, or where the plates meet, is running through the middle of it. And does anybody know what this country is called? Fantastic. Yes, this is New Zealand. And New Zealand is famous for its fantastic landscapes and scenery. And those fantastic scenery is often formed from its volcanic activity, from the fact that it is on this boundary. And earthquakes happen so frequently in New Zealand that children in schools have to be prepared for what to do if an earthquake happened. So like we might do fire drills if we heard an alarm going off if we were at school, we have to practice what to do if the alarm sounded. Children in New Zealand have to practice what to do if an earthquake is felt or if an earthquake alarm were to go off. and they're told that they need to drop down onto the ground. They need to cover their heads and their bodies with a desk, and they need to hold on to that desk leg to make sure it doesn't wiggle away. Any ideas why they might want to try and protect themselves under a table? Yes, if you have a look at the room that you're in now, there's probably things which are on the wall or above you. So there might be a light or a picture or a mirror. You don't want any of those things to accidentally fall on your head if the earth is moving. So mostly it's to just protect yourself from anything that might just tumble off the walls towards the ground. Fantastic. Okay, so earthquakes tend to happen where our plates meet each other. Let's move on to our volcanoes. So again, here we've got lots and lots of pictures of volcanoes. What can you see in all of my pictures? What sort of things can you see? So we can see some rocks, we can see some lava, ash, steam, magma, mountains, clouds of ash. Fantastic. So we can see a lot of different kinds of volcano here. And volcanoes actually have three main life stages. So the first life stage of a volcano is the one that we're used to seeing pictures of. They're the volcanoes that are erupting, they've got lava, they've got ash, they've got gases. What do we call that kind of volcano? Fantastic. Yeah, so they are our active volcanoes, and they're the ones that we hear about in the news. They're the ones which we see pictures of, and they tend to be the ones which are the most dangerous. Okay, so after a volcano has been active, it might not erupt again for over 10,000 years. What do we call a volcano that hasn't erupted for a long, long time, but it might erupt again one day? Oh, brilliant. Yes, this is our dormant volcano. It means sleeping. So it's not stopped erupting forever, maybe. It's sort of resting, it's hibernating, it's sleeping. That's our dormant volcano. And what do we call a volcano that will never erupt again? Brilliant. Yeah, just like we say about the dinosaurs, these are our extinct volcanoes. They will never be active. We will never see lava coming out of these volcanoes again. So again, we've got a blue star on our screen. Let's quickly nip to our sheet, and we can see we're on the last section of the stages of a volcano's life. So you can fill in these little boxes here. Okay, so we've got three of these different life stages of a volcano. We're going to be focusing on the active volcanoes now, because it's the active volcanoes which have the most interesting things occurring. So first of all, where can we find our active volcanoes? Well, just like our earthquakes, active volcanoes happen along our plate boundaries, along where these plates meet each other. And if we look at this little video, we can see here we've got little green triangles. These show us where our volcanoes are. And you can see that there's a lot of patterns. So I'll play this and you can see where we will find our volcanoes. So again, yeah, we can see if we follow the lines, volcanoes tend to form in lines. And those lines follow our plate boundaries. So we can see here, all of the volcanoes are along these plates here. If we remember, volcanoes happen where one of the plates is being destroyed, melted, and it comes back up. It's magma, and it also can happen where they're moving apart from each other. But there's another way that volcanoes can form as well. And an example is this volcano here. Does anybody know what we call these volcanoes that form away from the edges? Such as Hawaii. Oh, fantastic. Somebody knows? A lot of volcanoes actually form underwater. If we have a look at where some of these are, you can see that although they're on the edges of the plates, they're still underwater. So we do get a lot of underwater volcanoes along our plate boundaries. But this one here is what we call a hotspot. And it is exactly what it describes. It's a hot spot in our mantle that brings hot magma up through the crust. So this is our hotspot right here. And our hotspot always stays in the same place. But remember, our crust is always moving. So when our hotspot stays in the same place, over time, a volcano will form, then the plate will move, and the volcano will become extinct. There's no magma here anymore. So this is an extinct volcano. And a new volcano forms here. So you get another little volcano next to it. And then it keeps on moving. The hotspot stays in the same place. And we get another volcano forming. So now we've got 3 volcanoes in a row. And this is how we get volcanic islands. We get lots of volcanoes that form one after the other. The newest is on top of the hotspot, the oldest is further away from it. And as I said, this is such as places like Hawaii, where we see these hotspots or volcanic archipelagos. Okay, so now that we've seen a little picture of a volcano's insides, we need to look at the bigger picture and try and understand it a little bit more. So on your activity sheet, I'd like everyone to turn over as we're going to look at the inside of our volcanoes. And the inside of our volcano here, we need to start with this bit down here. So what do you think this is at the bottom of our picture? So this is our magma, and we describe where our magma is as our magma chamber. So this is a large space which has become filled with liquid molten rock. This is our magma chamber. And our magma moves from the chamber upwards, it's pushed upwards through this bit here. So what might you call this part here? Oh, these are some great, I think we should call it a magma tunnel. Unfortunately, that's not what we call it. It would be a much better name for it. And the straw, I like that one too. But we call this one the pipe. So the magma chamber, the magma travels up through the pipe here. And eventually we get to the top of our volcano. And some of you suggested this. This is where we find our vent. So our vent basically is the area that our magma can leave the volcano, that it can get out under all of the pressure that it is feeling up through this bit. And when our magma comes out of the volcano, it suddenly has a different name. What do we call magma when it comes out of the volcano? Oh, fantastic. Yes, we call this our lava. So when molten rock is underground, we call it magma. When it is above the ground, we call it lava. Helps us to understand what we're talking about, whether it's hot, deep underground, whether it is extrusive above the ground. Okay, now we've done our magma's journey up through the pipe, down to the vent, and then out as lava. We can now see that we've got 1, 2, 3, 4, 5, 6 different layers of our volcano. What do you think these layers are? Oh, perfect. Yes, these are old eruptions. And these are old eruptions, and they're layers of ash from when the volcano erupted. So when the ash comes out of the volcano, it settles down and forms layers. So we can count how many eruptions a volcano has had by counting how many layers of ash have been deposited or dropped down. And last but not least, what do we think that this large grey mass at the top is? Fab, yes, this is our ash cloud. So ash has been released up into the atmosphere. So we can get those parts of our volcano down into our sheet. And then we're going to move on to what comes out of our volcanoes. So first of all, we have already said that this is an ash cloud. And ash clouds are formed from teeny tiny pieces or fragments of rock. They're about 2 to 4 millimeters across, so they're really very, very, very small. And when a volcano erupts, those tiny little fragments of ash fire out into the atmosphere. And they can travel a very, very long way. In fact, we're going to watch a tiny eruption now. Well, it looks tiny on our globe. It happened in Iceland in 2010. And from this video, we can see how far the ash from the volcano actually spread. So you can see it travels a very, very long way. In fact, a few days after the eruption, we can see that a lot of the ash was covering a lot of Europe here. And it meant that because of that eruption in Iceland, a lot of Western Europe was not able to fly planes for a few days because you wouldn't want to be flying a plane and risking getting lots of little bits of rock into the engine. So ash clouds can be quite disruptive. They can stop us traveling. They can also cause some breathing issues if we're breathing in lots and lots of it, although by the time it got this far, it wouldn't have been causing a problem. We wouldn't have been finding small bits of rock in the air. But ash is also very, very good for soil, very, very good for plants. So a bit of a mix. It's both dangerous, but also very, very good for farming. So on our sheet, we can find the word ash clouds. We can find the picture of the ash clouds, and then we can match it to the description. Made up of tiny black rock fragments, can stop planes from flying. Okay, next one, we've got this rock here. Does anybody know what this rock is? I'll give you a clue if you're not sure. This rock is used, sometimes you might find it in a bathroom because it might be used to get rid of dead skin. Oh, fabulous. Yes, this is our pumice. And pumice erupts out of very explosive volcanoes. And I have a little video of what it could look like when a volcano erupts, releasing pumice. Okay, so you can see this huge cloud of ash, but also of bits of rock, including our pumice here. And it's full of tiny little holes, full of holes, so many holes, it can actually float in water. So we can actually match our pumice. We can go pumice, picture of pumice, rock with lots of air holes in from escaped gas. And it is very, very light. Okay, the next thing that comes out of our volcanoes could be volcanic bombs. Now, volcanic bombs are very heavy. Compared to our pumice, they definitely wouldn't float in water. And volcanic bombs are big spheres of lava. They will be very hot when the volcano erupts, and they can travel a long way. They can travel over 2 miles from the eruption. This is a picture of one in the museum. Here's a picture of a lot of different volcanic bombs, all of them very round. And this is a picture of a volcano erupting and releasing lots of volcanic bombs out into the ocean. Again, they're very dangerous. You wouldn't want to be near a volcano's vent that was firing these volcanic bombs because they're very, very hot and very heavy, very dense. So again, we go to our sheet, volcanic bomb, solid round lava that erupts out of volcanoes and can travel far. Okay, next one is probably the most dangerous kind of eruption or thing that forms from an eruption, and that is a pyroclastic flow. So we saw in the video a huge cloud of rock and ash forming. And when that volcano erupts all of this stuff out, it's very, very, very hot. And it can come tumbling very quickly down the side of our volcano. So it's very dangerous. It can destroy lots of things in its path. You wouldn't want to be near a volcano that has pyroclastic eruptions. And eventually, when all of the ash and rock settles to the ground, we end up with stones and rocks that look like this. We can see the tiny bits of rock, the larger pieces of rock, and the layers that it's been dropped down in as well. Very dangerous and very quick moving as well. It would destroy lots of trees very quickly. And the last one I'm going to show you, the last thing that comes out of volcanoes, if you play Minecraft, you might already know this one. Can anyone guess what I'm about to show you? Fantastic. Yes, we are looking at obsidian. And in Minecraft, how can you form obsidian? Brill. So in Minecraft, you need to put lava and water together and you get your obsidian. When a volcano erupts, if it has very, very, very hot lava and it erupts near very, very cold water and they meet, that's when we get our obsidian. It's also called volcanic glass because it's very shiny, very smooth. And classic view of it is this very smooth black rock. But we can actually get different colours of obsidian and different types of obsidian, including ones like this. This is called snowflake obsidian because it has white crystals inside it that look like snowflakes. Okay, so there are different objects that can come flying out from volcanoes. Most of what you've seen are things which are also in the museum, if you ever wanted to see them in person. But before we finish, I thought I'd just explain why some people, even though there's all of this danger linked with volcanoes, some people still choose to live near volcanoes, and there's lots of different reasons for that. So even though they're dangerous, we find people living near volcanoes. First of all, volcanoes are amazing and they're powerful, and people have always enjoyed trying to learn about them and to see their power. So tourists have always been drawn towards volcanoes. Here's a picture we have in the museum of a Victorian lady in her Victorian dress, and she's got her parasol, and she is standing on top of a volcanic mountain, and we can see the steam rising up here, possibly some of the gases erupting from the volcano, because people have been visiting volcanoes for a long, long time. And likewise here, we've got our picture of a lava medal. This lava medal was formed from the lavas of Vesuvius, and was created to sell to tourists when they went visiting the mountain or the volcanoes of Italy. So people live near volcanoes because they can make money from tourists visiting those areas, having hotels, they need food, they want souvenirs, tours. There's a lot of opportunity for work if you live somewhere which draws tourists. Secondly, we mentioned it very quickly, is that the ash from volcanoes is very, very good for soil. In fact, if ash erupts from a volcano, comes down to the ground and mixes with the soil, it provides lots and lots and lots of minerals, vitamins, things that plants need to grow very well. So Some people, especially if they're farming, producing food, they would choose to produce that food near to the volcano because they can get huge amounts of food, good quality food to sell on. Lastly, or another reason, there are more reasons than this, another reason is because of minerals. So when volcanoes erupt, they can bring lots of rare minerals from deep underground. Some of these minerals you can see here. So you have things like fire opal, this beautiful color. And does anyone know what this purple one is called? Oh, amazing. Yeah, this is amethyst. And people like having amethyst because of the beautiful color, and it's used in jewelry, and it's used as little trinkets, and again found near volcanoes. Does anybody know what this little white one is found in this rock? Give you a clue, it's very expensive. Yeah, this is a diamond, and diamonds can be found near to volcanoes. They're brought up through those pipes that we were looking at from the magma chamber. So volcanoes can also be very useful for mining these important and expensive minerals. So they can tell us a lot of reasons why people might want to live near them. And just before we finish, I just thought I'd show you some of the other minerals that we have in the museum, not all from volcanoes, but also trying to show why it might be that people choose to live near to some of these minerals because of how incredible they are and the huge variety that we can find. So in the museum, we have our mineral case here, and we can actually pick out some of the minerals I just showed you. We've got fire opal here, and we've got the yellow sulfur here. We've got the amethyst down here. So minerals can come in all sorts of different shapes, different sizes. We've arranged them by colour here, but we could arrange them by the shape of them, any different properties we wanted to. And the final thing I wanted to show, linked to our minerals, is one of my favourite properties of certain minerals. And some of these minerals can be found near to volcanoes, and that is that they sometimes fluoresce. So here we've got my favourite cabinet. This cabinet is full of minerals which under normal light look quite grey, white, beige, not as colourful as some of the other minerals that we saw. But I'm now going to shine a special light onto these minerals. It's called a UV or ultraviolet light, and you'll get to see what happens. So we can see that when we put that special UV light into this cabinet, all of a sudden we get these incredible greens and oranges and purples, all of these fluorescing glow in the dark minerals. So we can see that there are fantastic different properties that these minerals can have as well. And it's some of these properties that people want from the minerals near volcanoes. So that is our end to our tour about volcanoes inside and out from the Lapworth Museum. If you have any questions or anything that you'd like to know, Rona and I can stay for a few minutes to answer any questions that you have. And if not, if you want to visit the museum, if you're interested in seeing anything that we have or things that you might have seen today, then we are free to visit every day. So you're very welcome.